So talk about complex numbers. A complex number is a number that can be written in the form a plus or minus bi, which is very similar to what we were working with last time. So the numbers a and b are real numbers. So if you recall, a real number, if you look at my little graphic down here, that's your fractions, your whole numbers, your decimals, square roots of non-perfect squares. All of those are real numbers. And then I is the square root of -1 still. That is our imaginary number. So what the complex number does is it puts the two of them together. So you've got a real number part of it, and then you have an imaginary number part of it also. Complex numbers also have conjugates, just like our radicals do. So a plus bi and a minus bi are conjugates. Remember that conjugate, all you do is you switch that sign right there in the middle. So real numbers is simply a subset of complex number. Every number really is a complex number. So a real number is when your b value is a 0. So for example, if I have 3 plus 0i, do I really even have any i's there? No. So really all I have is the real number 3. So that's how it turns into a real number instead of being the complex ones anymore. And then our imaginary numbers are when your a value is a 0 and your b value is not a 0. So for example, 0 minus 4i. That's just purely an imaginary number because you don't have that first part. You don't have that a value there. So what we're going to be working with today is we are going to be working with manipulating our complex numbers a little bit more. We're going to be adding them, subtracting them, a little multiplying, a little dividing. So for number 1, we got to first take that square root of -24 and we have to simplify it down. So what's our perfect square that comes out of 24? 4. Square root of 4 is, and then remember we get that I because it is negative, so that becomes a 2i, and then we still have our radical 6. And then I just bring down my 7 and the minus sign. And then there's nothing else we can do. So I've got my real number section here. Okay, my real number, this is my imaginary number. Putting them together, there's your complex number. So it combines them both. All right, let's take a look at the second one. Number 2, I got that square root of -4. What does that turn into? 2i, because square root of 4 is 2. Because it was negative, it's I. So now I can do 3 minus 5. So that gives me a -2 for my real numbers there. And then the 2 times the 2i makes that a plus 4i. So I get -2 plus 4i. Third one, we got 4i plus 6i squared. So again, what does I squared simplify to? -1. So that's really 6 times -1, which turns into -6. And then we got our 4i. So just like I was saying before, your radicals need to come at the end. Your i's, same thing. Those need to come at the end because remember, I really is the square root of -1. It's really representing a radical. So those always need to go at the end. So now these next couple are kind of tricky. We have solve for x for number 4. We have 3 plus x minus 2i equals 3 plus 7i. So what they've done is they've taken a complex number and they've set it equal to a different complex number. So these first parts, they're already set equal to each other. Our real number aspect of the complex is already the same, 3 and 3. So what is true is your imaginary part is going to be equal to the other imaginary part. And that's how we're going to be able to solve for x. So x minus 2i has to equal the imaginary part from the other complex number, which is 7i. And the only reason why we have parentheses is because this is an x minus 2. It's a binomial. So they have to put parentheses around it so you know it's part of the whole thing there. So if I'm trying to solve for x, first thing I would do is divide by this I. But what happens with the i's on both sides? They both just end up canceling. So we have x minus 2 equals 7. So add our 2 over, and what does x equal? 9. So my second example there, we got to solve for x and y. So again, the first part has to equal the first part of the other one. So this is going to be 3x equals 6. The real number part equals the real number part from the complex. So divide by 3 and x equals 2. And so then the imaginary number from that one has to equal the imaginary number from the other one, because they are set equal to each other. Negative 5i is going to equal to negative 10yi. So trying to solve for y, first thing I would do again is get rid of my I. If I divide both sides by I, it ends up canceling, so I have negative 5 equals negative 10y. So the last thing we divide by, negative 10. So what do we get? 1/2. Or you could write it as 0.5, but still the same thing, still 1/2. So going on the back, when you have complex numbers and you're adding or subtracting them, it's very similar to adding and subtracting polynomials. You can only add and subtract the common terms. So the first one, I'm adding. So 2 plus a negative 5 would give me negative 3, because those are common terms. I can add those. And then 4i plus a negative 6i would give me a negative 2i. Very same rules as our x's there. And then there's our final answer for that. So you just add your real numbers, you add your imaginary numbers, and then it's done. 7 is a subtraction. So I'm going to carry my subtraction sign through. So now it's really kind of an addition problem there. So negative 3 plus 2 will give us a negative 1. Negative 8i plus negative 4i will give us a negative 12i. So negative 1 minus 12i is our final answer for that. Number 8, what should we do first? Yes, distribute this negative 5 here. So negative 5 times 4 gives us 20. Negative 5 times negative I gives us positive 5i. And then I just bring down the other one. Nothing happened to that one. So now 8 minus 20 will give us a negative 12. Yep. And then negative 4i plus 5i gives us a plus I. And then 9, we got to take care of those radicals first. We have to turn those into our i's, and then we can subtract. So the square root of negative 9 turns into 3i. Very good. Yeah. Square root of negative 144 would become 12i. So now the only thing we can actually subtract are the i's. So 3 minus 12 will give us 4 minus 9i. All right, go ahead. And then for number 11, you should have ended up with 8 plus 10i radical 2. Remember, everything turns to addition from that subtraction sign there. So I'm taking a look at number 12, express the sum of 7 minus I and its conjugate. Well, what is the conjugate of 7 minus I? 7 plus I. You just switch that sign in the middle. So when I add those two things together, what ends up happening to my i's? They cancel, so the sum would just be 14. That's always going to happen if you're adding conjugates, whether they're radicals or i's. When you add your conjugates, the last term always cancels. All right, let's review this. The cycles of I. Square root of -1 equals what? I. I squared is -1. I to the third is -I, and then I to the fourth is 1. I always make my little clock there. Have that right at the top of my paper so that I can always use it. A plus bi and a minus bi are called what? Conjugate. You gotta make sure you know what that word is. That word pops up a lot, especially in our Regents exam. So you gotta remember conjugates. Whether it's radicals, i's, just change that sign in the middle. So now their product, though, we didn't talk too much about their product yet. The product of the conjugates are the first two when multiplied together. So you would multiply a times a, which would give us a squared. And then minus your imaginary part, the bi squared. You could write it as b squared, I squared. So we're just going to practice a little bit more multiplying. We did a little bit of multiplying last time. We're just going to practice a little bit more of it now. So express the product of 2i times 3 minus 6i in the form of a plus bi. So we're just going to start with our distributive. 2i times 3 will give us a 6i. 2i times -6i would become 12i squared. So then again, I squared simplifies to -1, but when multiplied by this, -12 really makes it what? Positive 12. And again, you always have to rearrange it so that the I comes last, so 12 plus 6i. Do some more multiply, so I'm going to start doing my distributive. -5i times I squared would be -5i cubed. -5i times -2i will become 10i squared. And then times the 1 would give me -5i. So that simplifies our i's here. I to the third is simplifies to what? So it's really -5 times -i, which really turns into what? Positive 5i. Because that negative times that negative turns positive. I squared again simplifies to -1. So that makes that a -10. And then my 5i, nothing happens to that. That stays as 5i. So then what happens with my 5i's now that I've simplified everything? They cancel each other out. So we're just left with -10. So 3, express the product of 5 plus 2i and its conjugate in simplest terms. Its conjugate would be 5 minus 2i. Remember, just change that sign in the middle. So with conjugates, it's a little easier. Just got to multiply the first. So 5 times 5, 25. And then you multiply your last. So 2i times -2i would be -4i squared. But again, I squared, it's going to be the most common one. I squared is -1, so what does it do to the 4? Makes it positive, so 25 plus 4 makes that a 29. Now 4 is not conjugate, so you can't just do the firsts and the last. You got to multiply everything out because it's the same thing squared. So you're still going to have I as part of your answer here. So 2 times 2 gives me 4. 2 times negative I gives me a negative 2I. Negative I times 2 is negative 2I. And negative I times negative I gives me a positive I squared. So again, I squared is really negative 1. So 4 minus my 1 makes that a 3. Negative 2I minus 2I would be negative 4I. So 3 minus 4I. And then our last part, just like with our radicals, we cannot have an I in the denominator because, again, I equals the square root of negative 1. And we said you cannot have any radicals in the denominator. Still true. So since I really is a radical, you can't have I in the denominator either. So if I is part of a monomial denominator, so you have one term down there, all you have to do is multiply top and bottom by I. Doesn't even matter if there's a number with it. All you have to do is multiply the top and bottom by I. Now, if I is part of a binomial denominator, so that means there's 2 terms down there. Just like with our radicals, when there was 2 terms, you have to multiply by your conjugate. So if it was a plus bi, you'd multiply by a minus bi. So again, same rules as radicals, just a little bit different. So now sometimes, like in example number 5 here, you don't even have to rationalize it, because if we look at that denominator, 3I squared, can I simplify I squared? Yeah, so I would want to do that first. I squared is really a negative 1. So then times my 3, all that does is that turns that into negative 3. So now we can easily divide. What's negative 15 divided by negative 3? 5. So sometimes, as I said, rationalizing doesn't even need to happen. Just simplify what you got there. But then questions like number 6, I can't simplify I because that's as low as that's going to go. So I have to rationalize it. So I'm going to multiply the top and the bottom by just I because I have one term down there. So for my numerator, I'm going to do 3 times I and then I times I. So that gives me 3I plus I squared. In my denominator, 2I times I makes that 2I squared. So again, all of our I squares turn into what? Negative 1. So I have negative 1 plus 3I in my numerator. I'm still going to put the I last. That's always going to happen. My denominator turns into negative 2. Then there's nothing we can reduce, so we won't. Number 7, we have a binomial denominator, 2 terms. So I can't just simply multiply by I. What are we going to multiply by? The conjugate. So 7 minus 3I. So up top, 2 times 7, 2 times negative 3I. So I get 14 minus 6I. In the bottom, multiply my first because it's conjugates. Multiply my last. So it gives me 49 minus 9I squared. But that 9I squared turns into, yep, ends up being plus 9. So I get 14 minus 6I over 58. So again, it's minus 9, but it's times a negative 1. Can we reduce those? Yeah. We can divide them all by 2. So 7 minus 3I all over 29. If you can reduce, you need to reduce. Then our last one in the notes, again, binomial denominator. So we got to multiply by what? Conjugate. Keep saying that word over and over again in hopes that it gets ingrained in your brain. So 2 plus I. So this time our numerator, just a little bit more work to multiply it out. So I'm going to distribute my 8. So I get 16 plus 8I. And then I'm going to distribute this I, so I get plus 2I plus I squared. Again, in the denominator, the conjugate makes it a little easier. Just multiply the first, multiply the last. So now let's clean this up. I squared is negative 1, so 16 minus 1 gives me a 15. Adding my i's, 8i plus 2i gives me a 10i. So then in our denominator, this I squared turns into a negative 1, so I'm subtracting a negative 1, which really means I'm doing what? Adding, so it becomes a 5 down there. So you can divide each of those by that 5. So 15 divided by 5 gives me 3. 10i divided by 5 gives me 2i.